Hello and welcome to Maths with Udom. I still remain your online mathematics tutor, Mr. Okon Udom. So today we are going to look at addition of mixed numbers with whole numbers. Mixed numbers and mixed fraction mean the same thing. So addition of mixed fraction or addition of mixed numbers with whole numbers. So that is what we are going to look at in our class for today. So let's start proper. So addition of mixed numbers with whole numbers. Okay, so this is what we are going to be looking at for today. Addition of mixed fractions or mixed numbers with whole numbers. Okay, so let's quickly move to our examples. All right, so our examples now. Examples. Okay, are we together? All right, so we have simplify the following. Simplify the following. Number one, 3 whole number 2/5 plus 6. Okay, and number 2, what do we have? We have 2 whole number 3/4 5/8, 1 whole number 1/3, and lastly we have plus 3. So these are our examples for today. Okay, so we are going to start solving them now. Examples. Solution. So we have two methods. Two methods can be used to solve the problems. Okay, we can approach each of the examples using two methods to solve the problem. Is that okay? So let's have our first method, method 1. Okay, method 1. What do we have for the number 1 example? 3 whole number 2/5 plus what? Plus 6. So if you look at this example, we have the mixed fraction with what? With whole number. So let's have the first example. The first example is that we're going to multiply the denominator by the whole number. So 5 times 3. 5 times 3 will give us what? 15. So 15 plus 2 will give us what? 17. So we have okay, let's see. 5 times 3, 15 plus 2/5, then plus 6. So 15 plus 2 is what? 17. 17/5 plus 6. Remember, every whole number, they have 1 as their denominator. So you put over 1 here. Okay? So what is the LCM of 5 and 1? The LCM of 5 and 1 is still 5. Okay? So we come here and we write the LCM, we write the division line, we write 5. Okay, so how many 5 can go in 5? 1. So 1 times 17 is still what? 17. Plus, how many 1 can go in 5? Is 5. So 5 times 6 is what? 30. So if you add 17 and 30, you get what? You get 47. Okay, so that is 47 divided by 5. 47 divided by 5. So how many 5 can go through 47? That is 5 times 9 is what? Is 45. Okay. So we have 9 times. That is 9 whole number. Okay. Remember what? Remember 2. Because 9 times 5 is what? Is 45. 9 times 5 is 45. 45 remainder 2. So we have 2 over 5. So our answer is what? 9 whole number 2 over 5. So come to this corner and write 9 whole number 2 over 5. We are going to keep this and come back to that later, because we are going to look at the second example right away and then compare our result with what we got here. Okay, so let's move to the second example on how to solve this problem. Okay, the second method, rather, method 2. So let's have method 2 to solving this. Now, to solve this problem, method 2. Okay, so we have, it's still number 1 we are doing. So we have 3 whole number 2 over 5 plus what? Plus 6. So this time around, we are going to separate the whole number from the fractional part, the whole part from the fractional part. So 3 and 6, they are the what? They are the whole part. So we bring them together. So we have 3 plus 6. Then the fractional part is 2 over 5. 2 over what? Over 5. So what the next thing to do is to add the whole parts together. So 3 plus 6 will give us what? 3 plus 6 is what? Is 9. So we have 9 plus what? 2 over 5. And then the next thing is that we match the 2 together. Okay? So that would be what? 9 whole number 2 over 5. Okay? 9 whole number 2 over 5, which is exactly the same thing we got here when we did the first method. Okay? The same thing was gotten. So which means you can use any of the methods to solve problems in your exam or in your assignment. Is that okay? Now let's move to our example 2, the second example. So example 2, we also have 2 methods we can use to solve example 2. Okay? So what do we have in example 2? Let's move to first method, method 1. What do we have there? 2 whole number 3 over 4 plus what? 5 over 8 plus what? 1 whole number 1 over 3 plus what? Plus 3. So for this method 1, we are going to convert the mixed fractions into what? Into improper fraction, and then we'll simplify. Okay? So let's start. So 4 times 2 is what? 8. 8 plus 3 will give us what? Will give us 11. So we have 11 divided by 4. Okay? Plus, this is already a proper fraction. We write it. Plus, let's convert this mixed fraction into improper fraction. So 3 times 1 is 3. Okay? Plus 1, that's 4 over 3. Okay? Now, after that, then I told you earlier on that every whole numbers, they have 1 as their what? As their denominator. So what do we write? Plus 3 divided by 1. So the next thing is for us to find the LCM of all the denominators. What are the denominators? 4, 8, 3, and 1. So we come here and find the LCM of 4, 8, 3, and 1. So what can go through? So 2 can go. 2 in 4. 2 in 4 is 2. We write 2. How many 2 can go in 8? We write what? 2 in 8 is 4. Then can 2 go in 3? No, impossible. What do we do? We repeat 3. And then 2 in 1 is 1. What can go again? 2. Remember, we are looking for the LCM. 2 in 2 is what? Is 1. 2 in 4. 2 in 4 is what? Is 2. And then 2 in 3, impossible. You repeat that. Then 2 in 1 is what? Is 1. And then 2 can go again. So 2 in 1, repeat 1, 2 in 2, 1, 2 in 3, impossible, 2 in 1, you repeat that. And lastly, 3 can go. So 3 in 1, 1, 3 in 1, 1, 3 in 3, 1, and 3 in 1, 1. So our LCM will now be, we multiply all the numbers outside here. And that will give us what? Okay? So our LCM is what? 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. So let's do 2 times 2 is what? 4. 4 times 2 is what? 8. 8 times 3 is what? 24. So our LCM is what? Is 24. So what do we do with the LCM? We now come to this side and continue. So we write our division line. We write our what? Our LCM. Is that okay? So we now start simplifying further. How many 4 can go in 24? 4 in 24 is 6. Okay? So we have 6 times our numerator 11. Okay? So 4 in 24, 6. 6 times our numerator 11 plus, remember we are doing addition all through. Okay? Plus, plus, plus. Now, how many 8s can go in 24? Okay? 8 in 24 is what? 3. So we open a bracket again. 3 multiplied by our numerator 5. Okay? Now, how many 3 can go in 24? 8. So plus, open bracket, 8 times our numerator 4. Okay? And lastly, plus, how many 1 can go in 24? 24. 24 multiplied by what? Our numerator. So we open bracket, we have what? 24 multiplied by what? Our numerator 3. Okay? So that is what we have. So the next thing is that we are going to continue to simplify this so that we can get our answer. Okay? So we'll come to this side and continue. So what do we have? Okay, so let's continue. For our numerator, we have 6 times 11 will give us 66. So we write 66 plus 3 times 5 will give us what? 15. We write 15. Okay, are we together? Then 8 times 4. 8 times 4 will give us 32. Plus 32. Plus, then 24 times 3 will give us what? 24 times 3 will give us 72. Okay? We'll come here and write 72. Everything divided by what? Our denominator, 24. Okay? So the next thing is for us to add all the numerators together. 66 plus 15 plus 32 plus 72. If you add all this together, you are going to get 185. Okay? 185. So you come here and write 185 divided by what? 24. So this is an improper fraction. We need to break it down to what? A proper, to a mixed fraction. Okay? So how many 24 can go in 185? So 24 in 185, that will give us 7. Because 7 times 24 will give us 168. Okay? So we have 7. Okay, 168. So 185 minus 168, that will give us 17. So 17 over 24. Okay, so our answer is 7 whole number, 17 over what? Over 24. Is that okay? All right. So we'll come to this corner and put our what? Let's write our answer in this corner. 7 whole number, 17 over 24. We are still coming back to that, okay? So let's just circle that and keep it in a corner. So that at the end of the day, we'll compare our answer with this one. Because we are going to get the same answer. Okay? 7 number, 17 over 24. So let's quickly move to the second method in solving this. So method 2 right away. So method 2, how do we solve this? So we have 2 whole number, 3 over 4, 5 over 8, 1 whole number, 1 over 3, and 3. Okay, so to solve this using the second method, we separate what? The whole parts or the whole numbers from what? From the fractional part, the fractional numbers. Okay, so what are the whole numbers? The whole numbers are what? 2, 1, and 3. So these are the whole numbers. So we bring them together, and that will give us what? 2 plus 1 plus 3. So these are the whole numbers. Okay. So the next thing is that we also add the fractional part together. So plus, we open a bracket. For the fractional part, we have 3 over 4 plus what? 5 over 8 plus what? 1 over 3. So what do? We add the whole parts together. That will give us 2 plus 1 plus 3. And that will give us what? That will give us 6. Okay? So 6 whole number plus. Then we'll come to the other parts. What is the LCM of the denominators? 4, 8, and 3. We have done it before. So the LCM of 4, 8, and 3 will give us 24. We have done it before. So we'll come here and write 24. Okay? So the next thing is that we are going to, okay, how many 4 can go in 24? 6. Okay? 6. So 6 times our numerator 3. 6 times 3 is 18. Plus, how many 8 can go in 24? How many 8 can go in 24? 3. So 3 times our numerator 5 will give us 15. Plus, how many 3 can go in 24? That's 8. 8 times our numerator 1 is still what? Is still 8. Okay? Let's close these brackets. So from here, where do we go from here? So we now come to this side and write our whole number 6 plus. Now, can we add all the numerators together? If you add all the numerators together, 18 plus 15 plus 8. 18 plus 15 plus 8, that will give us 41. Okay? So 41 divided by 24. 41 divided by 24. The next thing is that this whole number 6, we are going to write 6 over 1 because all whole numbers, they have 1 as their denominator. So from here, the LCM of 1 and 24 is 24. So we come here and write 24. Okay? 24. So the next thing is that how many 1 can go in 24? How many 1 can go in 24? 24. So 24 multiplied by 6, and that will give us 144. Okay? 144. Plus, how many 24 can go in 24? 24 in 24 is what? Is 1. 24 in 24 is 1. So 1 times 41 is still what? Is 41. So what do we do from here? We are going to add 144 plus what? Plus 41. So 144 plus 41, that will give us 185. 185. So we come here and write 185. Divide by what? 24. Okay? So how many 24 can go in 185? That is 7. 7 whole number. Remember what? Remember 17. 17 divided by what? 24. Can you see that we got the same answer with the former one? That is, when we use the first example gave us 7 number 17 over 24. The second method also gave us 7 number 17 over 24. We got exactly the same answer. So you can use any of the methods in your classwork or in your examination. So quickly, we take your assignment right away. Let's have our assignments. Okay, let's take our assignment for today. Assignments. So for your assignment, you have to simplify the following fractions. Simplify the following what? Fractions. So let's have the assignment right away. Okay? Number one. What do we have in number one? We have 5 whole number, 4/9. We also have plus 7 whole number, 4/3. Then number 2, number 3, number 4, and then lastly number 5. Okay, these are your 5 assignments. So what do you do with the assignments? You solve the problems, submit this your answers or your work to your school teachers or your parents. Let them cross-check. Give to your school teachers, most importantly. They will mark it for you, give you your appropriate marks, corrections will be done, and then by so doing, you will get better by the day. Okay? Now, before you leave, kindly like this video. Drop your comment in the comment section. Share this video to all your friends all over the world. And most importantly, click on the red button, that subscribe button under this video. Click on it. That will encourage us to do more educative videos for you. Remember that the only way to improve in mathematics, to know mathematics, is by constant practice. You constantly practice different problems under different topics in mathematics. By so doing, you get better and you become mathematicians. Until I come your way again next time, my name still remains Mathematician Okon Udom. And I'm saying to you, remain mathematically smart and mathematically sound. See you in my next class. Bye for now. God bless you.